then I'm forcing you to do it that way. Okay. So some of you guys, real quick, I'm glad you said that. Some of you guys did the appendix, but you did long division. The whole idea of that appendix was synthetic. So I told you to redo it. So this one, so real quick, let me build up to this. What is the square root of 16? Why?
4 times 4.
And why are you saying 4 times 4?
Because 4 squared.
Good, because this is a square root, so it's an understood what here? 2. I just don't write the 2 because it's the most used root. So we just said, let's not write a 2, and if there's nothing there, we know it's a 2. I like it. Sort of like how x has a 1 in front, a 1 up here, a 1 down below. Holy shit. We just don't write any of those 1s, we just understand that they're there. Right? So the square root looks for something that it takes 2 of to multiply to be this. What does the cube root look for?
3.
What does it take 3 of to multiply to be this? And that, of course, is 3. 3 times 3 times 3 is 27. So what would this look for? Some of you guys might know what that is. Yeah, why is it 2? Because this is looking for what does it take 5 to multiply by itself to make 32. I like it. So when we get to this point, we're not officially here yet. If you're not sure what it would be, you just start to break it down. And you see what is it made of? 1, 2, 3, 4. Oh, it takes 5 2s to make 32, so the 5th root of 32 is 2. All right, maybe. So that problem just says plug some stuff. In fact, I just think I did part of the problem right there. One thing it said is plug a 27 in. What about, can you do the square root of negative 4? With a real number? No, because 2 times 2 is 4. Negative 2 times negative 2 is 4. Oh shit. But what about the cube root of negative 8?
Yes.
Totally. Because 3 things, let me cancel the right things. These 2 cancel, and there's 1 negative left. So 3 things could come out negative when you multiply them. So of course, what would it be? Good, negative 2. I like it. So cube root, odd roots can handle negatives. Even roots can't. Just because in even root, all the negatives would have canceled. There can't be a negative at the end. Okay, maybe. That's all I want to say about that. So that should be good for that problem. Is that right? Who asked that question?
Yeah.
Yes, okay. All right. So that was related to number 24 in 8.1. Okay. Anything else from homework? Yes.
I have a question from the older homework.
Sure.
Number 82 and 7.1.
Okay. So 7.182. So, the idea, what's the idea of polynomials inside fractions? And I'm asking you to simplify it. So if I have a fraction, what I want, the idea is I want to factor so then I can see if anything's common so I can kill it if it's common. You guys with me? All right. Sounds like a really pompous.
Kill him. He's common. He's a common folk. Kill him.
So all you got to do is factor all the parts, right? So now you just got to know how to factor this. That's really the question. Then, how do you factor that? What do you do?
That's 5 roots 2. Oh, what, 10, negative 10.
Yeah. So 5 times negative 2 is negative 10. What factors in negative 10 make 3? Well, it's actually staring you in the face. 5 and negative 2. They add to be 3. You guys kind of with me here? So there are other ways to do this. I just need to see some work as to what you're doing.
For the factoring part, you understand the X method, right?
Yes, that's the same thing I do.
Or the AC method or whatever.
That's what I'm doing.
Okay, yeah.
I try not to sound like, I don't know. If it helps you, great. I don't see the magic behind it, to be honest, because I do the same thing. I just don't write 3. So here you would put like a negative 10 here and a 3 there, is that right?
Mm-hmm.
Alright, so I'm just saying, there's my negative 10, and then there's my 3. You know, but if that helps you, cool, I love it. I'm not gonna, shit, if it helps you, I'm not gonna go, don't do it. I love it. I just don't get it. I don't know why it helps, but
Just because you see.
it's more visual,
Yeah.
more like compact, maybe? Okay, okay. So that'd be 5 and negative 2. So real quick, I'll do the top here. Let's focus on the top one. So then I can rewrite this as what?
5x squared plus 5x.
Good. So I would have put that first, but it doesn't matter. Who cares? And then you do GCF on both, right? What comes out of these two? 5x. Good, plus 1. So what has to come out of here? Negative 2. And remarkably, it's x plus 1. Yay! So then the top will become 5x minus 2. So that's what you would put on the top. Now do the same thing with the bottom. And then kill what's common. Some of you guys might realize that might be a good hint as to what might be a part of this. You know, I showed you that way. Or you just do this the same way we just did the top. You do it exactly the same way. Are you guys cool with that? I can't read in. Some of you guys, I don't know if you ate something bad this morning. Or that's just the way you look in math class. I don't know. I can't read you. Does it make sense what I'm saying? So they're just going to put stuff here and here, all the different. There could be a cubes, there could be a squares, there could be a grouping problem. The idea is factor everything and then kill whatever's the same on the top and bottom. That's the idea. The idea is what's more important. Now you also have to know the idea of how to factor the things that are there. But it's a separate kind of idea. Alright, cool. Is that good enough?
You kind of skipped a step, so I'm.
Oh shit! What step did I skip?
I'm very visual, so like
Yes.
going from 5x squared plus 3x minus 2 to 5x squared plus 5x minus 2. Like, I don't know how you got that.
Alright. If I wrote this, and then I said, okay, let me write, did I just write something different? No, that's 8. That's a representation of 8. So is this, so is this.
Right.
Do you see? So these are all different ways to write 8. And sometimes some of them might be more useful than others. Okay, so that's one idea I want you to realize. I can always replace something with something equivalent to it if that equivalent thing is better for me. So, I know what to do if I have a problem like this. Keep it simple for myself. Yeah. I mean, what would you do if you saw this kind of problem and I said factor it? What would you do? What method would you use? Grouping. I love it. You got to know that. Why would you use grouping? Because you see 4 terms, right? 3 terms is AC method or whatever. 2 terms is squares or cubes, right? That's the beautiful way to organize that in your brain is think about how many terms are there. So the whole idea with the method I use for doing this is to take this and make it 4 terms. Well, what's one way to do that? Could I say 5x squared plus 10x minus 7x minus 2? Now let me stop there for a second. Did I just write something different?
Yes.
No. What is 10x minus 7x? So aren't these the same?
Yes.
But what is, I wrote it in a different form. Just like 8 is another form of 6 plus 2. This is another form of that. And why is this form at least looks better? Because what would I try to do? Group. Will it work? You can see quickly that this won't work, right?
Yeah.
So, but, because how many ways is there to rewrite 3? Infinite number. 11 minus 8. 12 minus 9. 13 minus 10. You guys see what I'm saying? You don't have to say it like that, sorry. I'm not trying to be a jackass. Well, sometimes I don't have to try hard to be a jackass, but... So I need to, the reason we do this then is to come up with the correct way to split this up that the grouping will work for. So the grouping will have numbers that are related to what these are. That's the whole idea. That's why those are there. The middle term comes from the parts of the first and last term. That's why doing this allows me to find the numbers that I want to use to break the middle term up. So I still have the 5x squared. I still have the minus 2. I just rewrite 3x as 5x minus 2x. And then I'm allowed to try to group, and I'm guaranteed the grouping will work if I can find these numbers from this. That's awesome, no matter how you put them in there. But I really want it to make sense. Why am I allowed to do this? I can replace anything with something equivalent any damn time I want to. Hopefully it's useful, right? I could replace 7 with, second? 3 plus 4. It's amazing. Anywhere you want to in the universe, you see 7. How old is he? He's 3 plus 4 years old. Well, you're a weird person, but technically you're right. Do you guys see what I'm saying? So it's not useful in everyday speech. How far away do you live? 3 plus 4 miles. I'm not talking to you anymore. Goodbye. Do you see what I'm saying? So here, it's useful to replace 3 with 5 minus 2. Is it earth-shattering? 3 is 5 minus 2. Holy shit, that's a headline. No, it's not earth-shattering, but look what it did for me. Now I can group because I made it 4 terms. I love it. Does that make sense? Cool. This is the thing I need you to do. At any point that I'm doing something that I'm just taking to be making sense and it doesn't, stop me. That's the whole point. That's why I'm here. Otherwise, it's just you just have a book. You can ask the book questions. Aw. Hopefully that works still. Okay. So you do the same thing with the bottom and then see who cancels. Yes.
7.6 number 96.
Oh yeah, this whole section. All right. We did not like this section. No, we did not. So this section is particularly rough because it has variables, but it also has a lot of fractions of the variables in them, right? So 96 that's the question, right?
Yeah.
All right, let me build up to it because 96 has its own interesting thing happening. So let's build up to it. So let's first do one like, I'll get out of there. Example. What do you got, Jeff? I don't know, man. So if I said A equals B plus C over 2D, and I want you to solve for D. All right, let me stop. What's the main problem with it wanting me to solve for D? Where is it? It's on the bottom. But I can immediately improve that situation. Don't even have to do that. Don't even really have to do that. But yeah, that would work too. I just got to multiply by 2. Right? Get the stuff out of the bottom. Well, I've only got one fraction, so how do I kill it? Multiply by its denominator. It's not multiple fractions, right? I don't need an LCD because there's only one fraction. So if I multiply both sides by 2D, it alleviates the problem. The problem is my variable is on the bottom. Okay, well, let's immediately make that not true anymore. Right? I've got an equation, so I'm allowed to multiply. So what do I need here?
2DA.
Yeah, 2DA or AD. I like it. Equals?
B plus C.
Why didn't I multiply 2D in here?
Does it cancel?
Because it died immediately. It's dead. It's not around. There's no ghost of it or something. Zombie 2D. No. Now I'm one step away from the answer. What is it that I'm trying to get by itself? And why is it not by itself? It's multiplied by 2a. So how do I kill it? Divide by 2a. That's how you solve any equations. You undo what you don't want there. I don't want 2a there. What's it doing? Multiplying, so I divide by. I see way too many people subtracting here. Subtraction can't kill multiplication. I know you want to get used. I don't want the 2. Let me subtract 2. Subtraction can't do shit to this. It's multiplication. Now division, look at that. Die. So D equals B plus C over 2a. Kabang. So a lot of times the first step in a problem that has fractions in it and your variables underneath something, just multiply by that. So now it's up top. Now you can say how do I get that piece by itself and then divide by the stuff I don't want. Then it becomes more normal. Kill the fractions first. So now, one step closer to your question. So here's a classic problem. Alright, so One part of the problem you asked me is it's fractional. One part of the problem that you asked me is there's multiple letters I'm trying to solve for, right? You said solve for B, there's several B's, it looks like. So if I ask you how many P's are up here, how many would you say? And you're wrong, there's only one. Haha. That's where you're like, Jeff, meds? What meds are you on? You did not take them this morning? But there's only one P because what can I do with the P? No, that's bad.
Plus one.
Yeah. How many P's are there? One. Good. There was one P that was distributed to both things. So I don't see the one until I take it out. Now, how do I get P by itself?
Just divide by the RT plus
Divide by the shit you don't want. It's P times shit. So then I divide by shit. Done. It's what we do. It's just that, are these like terms? Are they like terms? No. So what do we always do to solve any equation with like an x in it? We get all the x's on one side, all the numbers on the other side, and then divide by the coefficient, right? So here, I got all my p's on one side. Can I combine them? Shit. So the best I can do is pull it out, so then I can, this is kind of like the coefficient now. I can divide by it. So it's what I have to do when I don't have like terms. Alright, so finally. I don't know if I want to do the one you actually asked me, because I think that might be the only one that I signed with multiple. So let me do, no, there's 93 also, right? Haha. So let's look at 96, sure.
A minus B.
A minus B, and of course they ask you to solve for B. So this has multiple levels of trouble. Okay. All right, good old Dante's level of math, I guess. No, Dante reference. Okay. It's got fractions in it with variables in them, and especially the fact that my variable I'm trying to solve for is in the denominator or something. Problem number one. So that's problem number one to take care of. Problem number two, there's multiple B's, I think, when we really know there isn't. I just have to get to this point. So the very first thing I want to take care of, how do I do it? What do I do? Multiply by? A minus B. I love it. Because I want to take care of my problems. The first problem I can take care of easily is the fact that there's fractions. Since it's an equation, that's an easy problem to take care of. Kill the fractions, right? So this side, I get 2b. This side, I get a times a minus b. I like it. And then I can distribute here. Is that cool?
Yeah.
Okay. Be careful. These are two different variables, right?
What?
What? I'm sorry. What's up?
So you don't do a squared minus ab?
Definitely not, because this is capital A, and that's lowercase a. Two completely different variables. Well, why do we do that? Because, believe it or not, there are situations where you need 30 variables. So if you use every letter in the alphabet, I still need 4 more. Shit! So then I just use capital or lowercase, whatever I haven't used yet. You guys kind of see what I'm saying? So yes, that's true. Some of you guys make all A's become capital. Well, now you realize you got to be careful because that's different from that. And you're like, come on, math people, shit. It's bad enough using the letters. I know, I'm sorry, it's just too bad. So what's the next step? What am I trying to solve for? If I divide by 2, I haven't gotten b by itself because it's on both sides. So that I can take care of that problem easy now too. And we know how to solve an equation. How do you solve an equation? Get all the variables on one side. Have I gotten all my b's on one side yet? No. So that I know that's a step in solving equations. I know it. So then I just
Minus ab?
add AB. And what is 2b plus AB?
3b plus a?
Nope. Are these like terms?
No.
They are not like terms. So it's 2b plus AB. They are not like terms. Yes, ma'am.
Now, why would you divide B? Because the A is multiplied by B.
I'm not separating these two things. I'm trying to get all the b, anything that has a b in it, and trying to get it over on the same side. So I want to move this entire thing. If I divide by b, I have to divide everything by b. And then that makes more fractions again, which I don't want to do that. Okay, yes sir.
So that's B times 2 plus A.
I love it. So then the next step is what we talked about here. There's not really two b's. There's one in front of 2 plus a. And then the last step is always, pretty much always, divide by what you don't want.
Which is
2 plus
2 plus A.
Yeah, so it'd be AA over 2 plus A. If you want to say your capital A differently. Okay.
Are we going to use scratch paper on our test?
Yes. In fact, to be honest, you're going to have to use scratch paper on tomorrow's test. Yeah. I'm going to have all the questions. Yeah. Yes.
Calculator?
Yes, sure. Yes. In fact, you're going to have to use a graphing calculator for a couple questions. So you saw how few I have in that cooler bag. So if you don't want to rely on that, you probably should get one. You can borrow one from the library, you can rent one from the thingamajig, whatever. I will bring some, but I don't have an infinite number of calculators. I'm sorry. Okay, anything else from homework? Yes?
7.6
Oh yeah, good. Okay. So that's the kind of word problem I forgot to talk about yesterday.
7.6, 1 over 2.
Yes. I don't think I assigned many of these. I'm going to do one like it. Alright, so let's say I can mow a lawn in 3 hours. It's a big old lawn, don't judge me. But you can mow the same lawn in 2 hours. Because you do shoddy work, so what can I say? So then the question would be, this is what's called a work problem. You have this person can do it this long and this person can do this. What if they work together, assuming that they don't get in each other's way, right? We're assuming the ideal conditions, because if we had to assume otherwise, our equation would get disgusting. So assuming they don't interfere with each other, how long would it take us to work together? Well, what answer would not make sense? Give me an answer that would make sense. Don't tell me a negative, because that obviously won't make sense. Give me a number that would not make sense as an answer. Well, so negatives, I understand. Like 2 hours before you got there, it was done. That obviously doesn't make sense. What's a less obvious answer that does not make sense? 1 makes sense.
More than.
Yeah, more than either one of these. If it takes us 7 hours together, what? Alone, I could do it in 3. If you're helping me, we should be able to get it in less time than either one of us. So 1 makes sense. Oh yeah, so again, what assumptions are we making? We don't get in each other's way, we don't fight.
You see that Game of Thrones? Yeah, it was stupid. What the hell are you talking about?
Or the don't hug me, I'm scared. Anybody? No? Okay. You should look that up on YouTube. It's really freaky. I can mow on there. So here's how it sets up. The book has a slightly different take on it, which I kind of like, but I like this way a little better. So I can mow a lawn in 3 hours. You can mow 1 lawn in 2 hours. If we work together, we can mow 1 lawn in I don't know how many hours. That's how you can set up every single work problem, right? So this one is a pump in the pool or whatever. It's the same way. Same way. I can mow a lawn in 3 hours. You can mow the lawn in 2 hours. Together, how long does it take us to mow 1 lawn? I don't know. So there's X hours on the bottom here. Solve for X. Now you can see why it lives in this section. Because it's solving rational equation. So how would I solve this? Yeah, he needs 2x. He needs 3x. He needs 3 and 2, so 6. So now they all have 6x, so now I can multiply by 6x and kill. So I get 2x and 3x, I get 5x equals 6. Divide by 5, I get 5, Jeff. 6/5, which is 1 and 1/5 hours. What's 1/5 of an hour? No, it's 1/3 of an hour. 12 minutes. So it would take us an hour and 12 minutes. See, that's an hour makes a lot of sense. We're really close with an hour. It's less than either one of us alone, and it only makes sense if we work together, right? Now, again, a lot of the math we learn at this level is idealized. I don't consider losing wood in the teeth of a saw when I'm sawing wood, right? And when in reality that happens. But as you go through, you just add more terms into equations you know from earlier. That's how you do. You start with the idealized, and then you add shit. So if I throw a ball into the air, it follows a parabola. Well, there's air resistance. Okay, that's the next level. That's when we'll throw that in there and see what it really looks like. Do you guys kind of see what I'm saying? A little bit? Did I go too far there? Like, where's air resistance problem, Jeff? All right, I'm sorry. So 1 and 1/5 hour, 1 hour and 12 minutes. Cool. All right, maybe. So this is like if I can type 80 words in a minute, and you can type 70 words in a minute. Together, how many words can we type total in a minute? You know, same way, exactly the same way.
If we left it at 6/5, would we do wrong?
Do it again, sir.
If we left it at 6/5 after we divided.
Not really. You wouldn't be wrong, but this is where I think I said somewhere earlier this semester that it's normally, we make mixed numbers for sure when I have a physical problem. You know what I'm saying? Like if they said, how long does this board have to be? And you said 12/7 feet. What? You see what I'm saying? So mixed numbers are closer to what we would say in real world. Yeah, but if you said 6 feet, I'm not going to take points off. That's the right answer. Okay. Anything else from homework? All right. Let's do 8.5. 8.4 again. If you came in late, is extra credit. We started 8.5 last time, to be honest, because it's all about absolute value stuff. So let's remember what we talked about yesterday. So it starts off with the idea of, if I said the absolute value of x is 11, so that's an absolute value equation. What are the answers to that?
11.
The obvious one is 11, because the absolute value of 11 is 11, but also the absolute value of negative 11 is 11. So whatever I put in here, so I really want to make sure you understand. People lose it when I start putting more complicated crap in here, but what's the absolute value of y equals 11? What's the answers?
11.
So be more specific. Y equals 11 or negative 11. Alright, so what if it was the absolute value of 2m equals 11? 2m equals negative 11 or 2m equals 11. And then you have to do one more step. So when there's more complicated stuff inside, the first step is the same. Whatever's inside equals 11 or it equals negative 11. If it's got more shit on it, well, you want to get rid of that shit. I want to get m by itself. So then m is equal to negative 11 over 2 or m is equal to 11 over 2. Bam. Because people lose it when I start here and then I go here. I don't know, Jeff. Just put something down there. Okay. Sure. We lose the thing, but the absolute value of anything equals 16, that thing equals something or something else. So that thing
Equals 16 or negative 16.
has to be 16
That thing
or
equals negative 16.
that thing is equal to negative 16. I love it. Because if I just put an x in here, I'd say x equals 16 or x equals negative 16. So whatever the hell I put in there, if the absolute value is 16, then this must be 16, or it must be negative 16. I really want that to make sense. I don't stop here, though. That's the only difference. I don't just stop here. I got to figure out what x is. Here, that kicked ass. I'm done. There. Oh, man. So what do I do? All right, minus 5.
Divide by negative 7.
X equals negative 11 sevenths. People freak out here a little bit Negative answers are completely fine, right? In fact, we know I could put a negative number inside. It's just it can't equal a negative number, right? There's nothing you can take the absolute value of and have it come out to be negative. And then over here the same way, subtract 5, negative 7x equals
3, -21.
negative 21. X is 3. So either one of those answers makes it work, because there's one version of x that makes this a positive 16, and there's one version of x that makes this a negative 16. That's why there's two possible ways. All right, maybe. Is that cool? You guys get that? Let that be easy. Okay. Yes, sir.
But if you change the sign to the absolute value, like 5 minus 7x, why don't you change it to 5 plus 7x?
Why wouldn't I?
Yeah.
Okay, good. Okay, you ready? All right. The absolute value of 8 is what? 8. No matter how I make 8 look, the answer's got to come out to be 8. If I put an 8 inside absolute value, the answer better come out to be 8. And you're all like, yes. But, so, like our earlier discussion, isn't 10 minus 2 also 8? But if you do this, do you get the right answer? What's the answer? We know the answer is supposed to be 8. If I put something inside that's 8, the absolute value better come out to be 8. Well, 10 minus 2 is 8, ain't it? But if I do this, do I get the right answer? No. Why? Because I didn't take the absolute value of this number. I took the absolute value of a part of the number. Oh shit, I'm not allowed to do that. Do you see what I'm saying? I like it. So if I see absolute value of x minus 3,